Yes, if you're wondering, this is a witch hat and a with some hair. I'm going more wizard look if you're wondering. Anyway, we're doing 10.5 area of parallelograms. A parallelogram is like a square or a rectangle without any right angles. And you're going to have to identify a parallelogram, and you're going to have to find the area of them. And they could be sideways, so it looks more like a kite. Kites, a little bit different. Went over this in Study Island once again. Area of parallelograms. Stop the video, pause it, do your practice problems, take your notes. Alright, we're doing 10.5 area of parallelograms. And the biggest part about area of parallelograms is realizing that parallelograms are not that much different than a rectangle. Okay? So, if you read the story here about Jillian and her grandmother, she's quilting, and all of her little triangles and parallelograms, she wants to find out area of the quilt squares. So she needs to find the area of this parallelogram. Well, a parallelogram, just like a rectangle, you are going to take base times height, okay, or length times width. But realize that the height is not necessarily the side. That's diagonally. A height comes off the base at a 90-degree angle all the time. This is not a 90-degree angle. So I would take 2 times 4.2. And that's the way I would find my area. Do not get confused with this extra one. That would be used if we were doing perimeter, but not area. Okay? So as we go into this, you remember if you had to find the area of this rectangle, you'd just take 5 times 10. Well, this is very similar. This is very similar, except for now it is not 90-degree angles. You can see they took this rectangle and they just cut off parts of it and moved it to the other side just by making a line right there and a line right there and moving it. Okay? Putting this on the other side and taking this, putting it over here, and now I have my parallelogram. Okay? Actually, you don't really use that line there. Now I have my parallelogram, and it should have the same area as this because it's the same stuff. Okay? All right? We took them apart to get it. So, let's see if we can do a couple of these here. So, you have base and height. Remember what I said about the height is 90 degrees off of the base. You could count it off the top too. Same thing. All right. So if you look at that, off a 90-degree angle, we want to find the area. If they tell us that the height is 3 and the base is 8, even if I have these sides of 4, I don't worry about those sides of 4. I'm only worried about the base and the height. Okay? Not worried about that 4 over there. Alright, just this and this. Base times height, 3 times 8, 24 inches squared, or 24 inches squared like that. Either way. Alright, now I'd like to see if you can do some. Okay? Try and do that one right there, number 1. Let's see, part of it got cut off, supposed to look like this. Go ahead and try and do it. Hopefully you got 6 times 2 is 12, and centimeters times centimeters is centimeters squared. Okay, there's the height, there's the base, top and bottom would be the same. There's an 90-degree angle. Okay? Number 2. Go ahead and give that a try. No picture this time. If you needed to, you could draw one. I would take 9 inches times 3.5 inches. Multiply those together. Okay? 7. We get 31.5 inches squared. Okay? Questions about that? And then we do number 3. Base times height. If you want to make a diagram and do that, could. The base would be 5. The height would come right off the base at a 90-degree angle. That would be 3. Alright, you know that's going to give you 15 inches squared, or 15 square inches. Either way.